Okay, welcome to 12.10. We're still graphing, but I like this section a lot better. Instead of graphing by normal, we're going to do translations. So we're going to shift up, down, over to the left or the right, and it's just like some of the other functions that we've done, so hopefully it'll go a little bit better. Okay, like I said in the introduction, we're doing transformations. So we're just going to do like phase shifts, vertical shifts, things like that. So if we're looking at our standard trig function, notice how we've got our amplitude, we've talked about that, and our b, that's going to help determine the period. But if we have theta minus h and then plus k on the outside, that's going to do some very familiar things. So if we have a positive h, it is going to shift left. Oh, that's terrible. Left, and negative h is going to shift right. Now, remember that it's always the opposite because we have these negative signs right there. So don't forget that. So whenever we're looking at some examples, the h's are always the opposite of where I think they should be. So example A, y equals sine of theta minus pi. So that is going to shift pi units, and hopefully you can guess this, pi units to the right. So because the h right there is positive, we have the negative sign that's right there. So then the actual h value is positive. So that's why it shifts pi units to the right. So then example B, y equals tangent of theta plus pi over 4. So in that case, it's minus a negative. So our h is a negative number. So that means it's going to be pi over 4 units to the left. So this is the very same process we went through with normal functions. So hopefully we're starting to see a pattern here, maybe. So then vertical shifts. The k is on the outside of the trig function. It's on the outside of everything, and that one is kind of normal if there is such a thing as normal right now, but positive k units is going to go up k units, and negative k units shifts the graph down. So for example, we've got y equals tangent of theta plus 2 shifts 2 units up, and then negative 4 shifts 4 units down. So please note that these are on the inside of the parentheses, and which means they are a part of the trig function. These numbers are outside of the parentheses. This indicates that they are not part of the trig function. That's the thing that differentiates them from each other. So don't fall into that trap. Okay, let's put it all together now. So we're looking at our sine function right here with every single part that we know how to do. So remember, this A is our amplitude. That's how tall or short it is. This B helps us determine our period, how many times it repeats. And then we've got our phase shift up and down. Whoops. Our phase shift. And then K is going to be our vertical shift. So this is just a quick review, vertical shift, of everything we've talked about with a trig function. So hopefully using these properties, we can kind of graph a little bit easier. One of the ways that we talk about shifting graphs up and down is using this idea of a midline. So a midline is just that line that goes right through the middle of a sine wave or a cosine wave. And that's the thing that gets shifted. So by shifting the midline, you are shifting both the peaks, the top of the hills, and the bottom of the hills. Basically, this whole graph gets shifted up. So using the midline is one of the ways that we do that. So shifting a graph vertically will create a new horizontal axis called the midline. This reference line is to which a graph oscillates. So that just means that this is the line that it's oscillating around. And then the equation of the midline of the new midline is y equals 4. So here it's y equals 0. Here it's y equals 4. So you can kind of see how the sine wave normally oscillates around y equals 0, and then now it's going to oscillate around y equals 4 because of this 4 on the outside of the angle. Okay, let's do a little bit of practice. So looking at number 1, we got y equals 1/2 sine 3 theta minus 5. So there's a lot going on there. So our amplitude is going to be 1/2, comes from right there. Our period is going to be 2 pi over 3. So remember, we have equations on my note card, and I got that from this 3 right here. Our equation for sine is 2 pi over b, and our b is 3 right there. So then our phase shift, phase refers to up and down. I'm just kidding, left and right, that's my bad. So our phase shift is going to be none. Okay, bad example, whatever. But then our vertical shift is going to go down 5 units. So we're going to write 5 down. And then our new midline, if we're going to oscillate around, is going to be y equals -5. So that's all coming from this one right there. So then we can do the same thing for our tangent function over at number 2. So our amplitude, and again, it's kind of weird to say because tangent technically doesn't have an amplitude, but we would still use this number to graph. We would put undefined though. I can't spell undefined. No, I got it right. Undefined. So our period, again, is going to be based on this number on the outside of the theta. I'm using an equation, and our tangent is pi over b. Our b is 2. Our period is going to be pi over 2. Our phase shift, so that's going to be left and right, is going to be from this guy right here. And we're phase shifting left 2 pi. Remember, inside of the function, there's that negative sign that just switches how things work. And then our vertical shift is going to be up 1. And then our new midline is going to be y equals 1. So for a tangent, remember our tangent looks something like that. So this dot would then be on y equals 1 as opposed to y equals 0. Okay, let's try some out. So looking at number 3, we got y equals sine 2 of all that other stuff. So I'm just going to start labeling what I know. So our amplitude is 1. That comes from the fact that there's no number right there, which means there's an implied 1. Our period comes from this number. And again, our period for sine is 2 pi over b. B in this case is 2, so we're going to have 2 over 2. So our period is just going to be pi. And then our phase shift, remember that's left and right. That comes from this one right there. So our phase shift is to the left, pi over 2. So pi over 2, and I'll write left. And then our vertical shift is none. And then our midline is 0 because it did not go up or down. So then from there, we know our amplitude is 1. So that's going to be kind of right like there. It's not an asymptote. I'm just kind of lightly drawing it there. And basically, since it's a phase shift to the left, so I'm thinking of first my sine of 2 theta. So if I can figure out where like the highs, lows, and or where it crosses the midline, then I should be good to go. So normally let's see here, sine of 0, what am I doing? I forget all this stuff. Let's see here, sine of 0 Okay, so sine of 0 is normally 0. So I'm going to put a light point right there, but remember, it shifted to the left pi over 2. So that means that we're going to cross the midpoint right there. That's going to be our big point. So then, let's see here. At sine of 2 pi, I don't know, at pi over 4. So here are my calculators in radians. So what is sine of 2 pi over 4? So that's at 1. So the reason I did that is I want to figure out whether I'm going up or down. So pi over 4 would be here. We moved this way. So we've got there. With just those 2 points, I'm good to go because I know my pattern for sines. And then we can just call it like that. And again, I'm looking very closely right around here. The rest of the stuff, I just kind of want to make sure that you know that it repeats. Okay, number 4, let's do the same thing. Our amplitude, so we are dealing with a tangent. So our amplitude is undefined, technically. But we would use this number to help us graph, kind of give us a rough estimate. So our period is pi over b. Our b is 1. Since there's no number, there's implied 1 there. So that's just going to be pi. Our phase shift is none because there's nothing inside of the tangent function there. So that's going to be none. And then our vertical shift is going to be down 3. Which means our midline is going to be y equals -3. So I'm going to just, again, this is not an asymptote, but I am going to draw a little dotted line. That's where my midpoints are going to be for my tangent graph. So if I look at my parent tangent graph, it starts off, let's see here, period is pi. So then half of that. These are actual asymptotes because it didn't move left or right. So those asymptotes are still good. So my normal graph is going to look like this. And I made it a little bit wider because there's a 1/2. But remember, it moved down. So our midpoint now is right here. So that's going to go up. And that's just going to go down. And then our period is pi. So let's see here. We have pi over 2, 3 pi, and our midpoint's going to be right there. And there you go. Number 5 looks like a good one to end on because it's got a lot going on, and you've now seen a sine, tangent, and cosine. So here we go. So looking at number 5, our amplitude is going to be 4. Our period, looking at the number right there, there is no number, so there's implied 1. I'm looking at my formula, 2 pi over b. b is 1. So our period is going to be 2 pi. Our phase shift is going to be to the right 3 pi over 4. So we're going to say to the right 3 pi over 4. And then we're going to have a vertical shift 1 down, which means our midline is going to be y equals -1. So I'm just drawing my little line right there as a midline. You don't necessarily have to draw that, but it helps me just to remember like where I'm talking about. Anyway, so we've got a phase shift right. But first, I want to know where my normal cosine is either 0 or 1. So cosine of 0 is normally 1. In this case, let's see here. We've got a phase shift to the right. So here's my normal. A phase shift to the To the right, 3 pi over 4. So that's 1, 2. That's 3 pi over 4. Our amplitude is 4. So that means from our midpoint, we're going to go up 4. 1, 2, 3, 4. So this purple dot is going to be our real dot. And that was cosine of 0. Okay. So now I need to find another good number to know. Let's see here. When does cosine equal 0? So that's cosine of, oh gosh, I gotta draw a triangle. That's not the triangle I wanted. So this is cosine. So at cosine 90, cosine of pi divided by 2. Cosine. So cosine of 90 is when it crosses the 0 axis normal, but cosine of 90 plus all of our transformations is where it's going to cross this line. And then from there, I should be able to draw it. So cosine of pi over 2 would be right there normally, but we have a phase shift to the right, 3 pi over 4. So 1, 2, 3. And then a vertical shift down. Oh, so then this would be our new point. So from that, I can make my pattern because I know how cosines work. So this is 1, 2, 3. 1, 2. Wait, 1, 2. Sorry, 1, 2. So then down here, it's going to be, I'm going 4, 1, 2, 3, 4 things down because that's our amplitude. And then 1, 2, 1, 2, 1, 2. And here is, oh, golly Jiminy Willikers, I missed. And here is our cosine graph, just using phase shifts. This is also why I like it a lot better than just graphing inverse functions. Inverse functions are scary.